Hi, in this video I'll explain about the ray diagrams for a concave lens. I'll use several object positions to make it easy to understand. We can see in this image a concave lens with the material thinning out at the center. If we were to chop that concave lens about its vertical axis, you will see a textbook representation. So the circumference is represented by the broad area at the top, and the center is shown as a thinned out area. If you draw a vertical line through the center of the lens as well as a horizontal line through that center, the intersection is marked with an orange plus and is called O as the center of the lens. Now the principal axis is very important. On that horizontal white line, we draw out F1 and 2F1. F1 is the focal point, is at the focal length from O. Similarly, on the right hand side, we mark out F2 and 2F2. Now let's look at an animation. So I'm rotating the concave lens and you can see the shape of that, and it's round in shape and the material is thinned out at the center. That's why when you cut it on its vertical axis, you see the shape that you see in the textbooks. So now we do the same thing. We draw the principal axis, mark out F1 to F1 on the left hand side, F2 to F2 on the right hand side. We plug in a light source, and so that the light rays will always travel from left towards the right. So the object is at infinity now. The green rays are coming in parallel to the principal axis, and they will diverge because the concave lens is also known as a diverging lens. You can see how they diverge after coming out from the lens after the refraction. These rays will never meet on the right hand side, so they have to be projected backwards, and you can see the dotted lines all converging at F1. Therefore, F1 is the focal point for a concave lens. Next, we will take up some object positions and we'll plug in an object in the shape of an arrow. The bottom of the arrow does not need a ray diagram because a ray of light is passing through that bottom. In fact, that's the principal axis. So the bottom of the image also will fall on the principal axis. Now from the top of that arrow, we surely need a ray diagram. So let's first take that green ray, which is parallel to the principal axis, exactly as we did for the infinity position. So that green ray is going to diverge and get projected backwards towards F1. The orange ray is new here. It's aimed towards the F2 on the right hand side. So it behaves opposite to the green ray. So because it's aimed at the focal distance F2, it emerges after refraction to be a ray which is parallel to the principal axis, as you can see the orange ray traveling. The blue ray passes through O without refraction. So when we project these rays backwards, they all intersect at a point which is the top point of the arrow. The bottom point I already covered. So we get an image that's virtual, erect and diminished, and the position of the image is between O and F1. Now let's move the object closer to the lens, and we put it at 2F1. When we place it at 2F1, we will do the same thing and draw the three rays that we drew before. And all the three rays will behave exactly as they did before. So the green ray will be parallel to the principal axis. It will refract and diverge and bend upwards, and its projection will pass through F1. The orange ray is aimed at F2. It will travel parallel to the principal axis, so we project it back with a dotted line. The blue ray goes through O without any change. Our question is, why don't we draw a ray through F1? That's possible, and the ray through F1 will hit the lens, diverge downwards, and if we project it back, it will all meet at that arrow that we have drawn as the image. The image here is again virtual, erect, diminished, and its position is between O and F1. The position of that image and the size seems to be consistent for different positions of the object. Next, we should move the object closer to the lens and put it somewhere between 2F1 and F1. Let's do that. it's almost the right point. So we stop it here and we start the ray diagram. We can start it anywhere actually between 2f1 and f1. So we have the three rays, and here again we could draw a ray through f1, which will be very sloping, and it will go down and probably hit the base of the lens. We don't want that, hence I haven't taken a ray through f1. But the three rays work well: the green ray, the orange ray, and the blue ray, as before. And if we project those dotted lines, they all meet in a very consistent manner and they form a very similar image, which is virtual, erect, and it is diminished in size, and its position is also between O and F1 as before. There seems to be not much of a change in the formation of the image. Now we move the object closer to the lens and we place it exactly on the focal point F1. So it's sliding forward, and here it is, it's come to F1. We draw the same three rays as we did before, and I will just repeat it. So the green ray, which will hit the lens, diverge upwards, projected back towards F1. The orange ray aimed at F2, it travels parallel to the principal axis. We project that also backwards, and we draw the blue ray through point O. Just a point of clarification, all these colors are just to make the image easier, and we can use white light and get the same result. We are not using different wavelengths of light in this animation. So you can see the image, which is virtual, erect, and diminished, and the fourth thing is this position is also between O and F1, which is very consistent. We have covered a lot of positions of the object, and the last position of the object can only be between F1 and O. So the object is being slided very close to the lens. It's almost touching the lens now. We can't move it very close. So we'll stop it somewhere here and draw our favorite three rays: the green ray, the orange ray, and the blue ray. The green ray will diverge upwards at the same angle because the ray is parallel to the principal axis. The orange ray aimed at F2 will travel parallel to the principal axis, and the blue ray goes through O without any refraction. And when we do the dotted lines and the intersection, we get an image which is virtual, erect, diminished, and position is between the O and the object. I hope this was useful to you. Thanks and have a great day.